In this video, I want to discuss taking a look at how to calculate, using StatCrunch, a t-test. So first of all, just as a refresher, real quick, right? Typically we have a flow chart that we go through to determine whether we're doing a z-test or a t-test, right? Whether we use a standard normal distribution or we use a t-distribution. So typically the first thing we want to ask is, are we satisfying the ability to use the central limit theorem? So the two conditions that we need to be able to meet for the central limit theorem is, do we know the population is normally distributed, or are our sample sizes large enough? Some books say the sample size of 30 or more is large enough. Some say 50 or more. So pay attention to your textbook. Now, as long as we say yes to either one of these, then the second question is, do I know the population standard deviation, sigma? Now, if the answer to that is yes, then we use a standard normal variable, right? We use a z-statistic. If the answer to that is no, then we use a t-distribution. Now, obviously, if I say no to both of these up here, then I can't solve the problem, right? So usually in an introductory statistics course, we say we stop. We can't solve that problem. So in this video, I want to look at, what if we meet these conditions and we do not know the population standard deviation? How do we use a t-statistic? So I have an example problem to look at here, and the problem says that a manufacturer claims that the mean life of its fluorescent bulbs is 1100 hours. So a homeowner randomly selects 46 bulbs and finds the mean lifetime to be 1070 hours, and the sample standard deviation is 80 hours. So test the manufacturer's claim, we're going to use a level of significance alpha equals 0.10. So again, I kind of had these a little bit backwards, but is n greater than 30 or the population normal is yes. And then the question is, do we know sigma? We don't know the population standard deviation, so we're going to use a t-test. Excuse me. So we look at the claim, and the claim is that the mean equals 1100 hours. So because that has equality, we're going to place that into the null. And there's our claim, and then the complement of that being the mean is not 1100 hours. Now remember, the alternative being not equal to means we have a two-tailed test. So if I just come down to my picture for a second, I'm going to take a look at the area, or the probability, in both the right and the left tail. Now typically what you see in a textbook with these problems is we're going to use what we call the rejection region approach, right? So one process is to use the p-value approach. We calculate the p-value and we compare the p-value to this value of alpha here. But the tables that you'd see in a book, we can't find probabilities under a t-distribution. So we typically take the rejection region approach. So that approach would be basically taking my alpha of 0.10, and since we have a two-tailed test here, we basically look at 0.05 in each tail, and we find the critical value that corresponds to that. So we would look in our standard normal table to find that value. Again, I don't want to go through the details of that because we're just talking about StatCrunch here. So take a look at my instructional video where we go more into that detail. Now, if I'm using StatCrunch to find this critical value, right, how could I find that value? So what I'm going to do then is I'm going to go to StatCrunch, and I'm going to click Stat, and I'm going to click a T-Stat. Actually, no, I'm not. I'm going to go to the calculator. I apologize. And I'm going to go down to the T calculator. Now in this case, I'm looking at two tails, so I got to click between. Now the weird thing here about this particular approach is I'm looking for what's in the right tail. Right? So we had alpha being 0.10 in the outer tails. So what I want is 0.90 between the two values. Right? So I want 90% of the area between my two values. Now, in this particular case, we had a sample size of 46, so our degrees of freedom is 45. So we'd put our degrees of freedom of 45. And then when we click compute, there's our critical values of 1.68 and negative 1.68 that we have on the worksheet here. 1.679, negative 1.679 were our two critical values. Now, I don't mean to get off sidetracked here, but just to point this out to you, if I was only looking for, say, 0.05 in the right tail, suppose I'm only doing a right tail test, right? What I would do with StatCrunch is I would go to the standard, I would choose, let's say, right tail, and I would do the 0.05 in the right tail, and that would tell me that. So in this problem, because we're looking at two tails, we have to choose the between. And again, the calculator in StatCrunch wants what's between. So we would have to take, like we discussed, the 0.10 collectively and put 0.9 here. All right, now back to our problem. For this problem, we found our two critical values. So then the next step would be to find the standardized test statistic. So again, our formula for the standardized test statistic is the sample mean minus the claimed population mean over the standard error. And again, in this problem, we did not know sigma. We did not know the population standard deviation. So we're using the sample standard deviation as an estimate. So for this problem, we were told that was 80. Now again, for our sample of 46 light bulbs, that sample had a mean of 1070, and then the claim of the population was 1100. So we plug all that in by hand, we get negative 2.54. So again, doing all this by hand, negative 2.54 would fall inside the rejection region, so we would reject the null hypothesis. Now, if I'm using StatCrunch, right, how do I do this? So I'm going to click Stat, and I'm going to go to a t-statistic. I have one sample, and I have the summary statistics, right? I have the sample mean with sample standard deviation. So I'm going to give the sample mean, sample standard deviation, and the sample size. Alright, so I've plugged that information in. I have also plugged in the equality from the null. Our alternative was a not equal to. I like to do the visualization of the plot. So plugging all that information in from my problem, plug the p-value plot. For me personally, I like that. It brings up this information. Now if I go to the graph for a moment, I want to point out to you that it is giving me a critical value. Oh, you know what? I forgot. So with the t-statistic in StatCrunch, it doesn't find the critical value for you. Right? So again, when I'm doing this work by hand, I can't find the p-value. I have to find the critical value. All right? So if this is a problem you're working on, you have to be able to look in the table to find that value. So the calculator, though, tells me what the p-value is. So interestingly enough, if the problem isn't asking me for the critical value, I could make a decision at this point. So my p-value is less than my alpha. My alpha was 0.10, and the p-value StatCrunch is giving me is less than that. So because my p is less than my alpha, I reject the null. Now, there's a quick decision process, but if the problem is asking me for the critical value, right, how do I determine that real quick? Okay, so I would have to have my t-distribution table pulled up here. And in this scenario, right, I'm looking at a two-tailed test here. Okay, so based on my two-tailed test of 0.10, we had 45 degrees of freedom. So I'm going to scroll down here to 45 degrees of freedom under my two-tailed test, and I see the 1.679 that we got as our critical value here. That was my 1.679. Alright, so again, my standardized test statistic fell into this region, and I want to point out to you that StatCrunch gives me that standardized test statistic. There's the negative 2.54 that we would have calculated by hand. So again, the distinction here is that even though StatCrunch gives me the standardized test statistic, it does not tell me the critical value, right? It does not tell me that critical value that we got from the table. But the decision process is still the same. So because our standardized test statistic fell into the rejection region, we reject the null, and based on StatCrunch, the p-value is less than the alpha, so we reject the null as well. Okay, now real quick, let's suppose that I'm not given the summary statistics. I'm not told in the verbiage of the problem what the sample mean and sample standard deviation are. Let's suppose I'm given the raw data. So again, I'm going to come over here to the right. I'm going to click to open in StatCrunch, and it'll provide the data for me in a column. So what I would do in this case is click Stat, go to T-Stat. I have one sample, and this time I have the data. So again, the data is in the column var1, so I'm going to click that, and then I'm doing a hypothesis test. Now for this particular problem that I pulled up, the claim, where's the claim? The claim is that the mean salary is $95,000. So I'm going to pull up StatCrunch and type in 95,000 here. Now within this problem I have a two-tailed test, right? So this is an equal to, so I have a not equal to. So I'm going to put the not equal to here. I like to do the p-plot, and when I compute, again, StatCrunch is not going to tell me the critical value. So it does give me the test statistic. It does tell me the p-value that I can make a decision for. So again, if I'm wanting to find the critical value in this particular case, I have an alpha of 0.01 and I have a two-tailed test. So bringing up my table, I see two tails. My alpha is 0.01 and my sample size is 16. So my degrees of freedom will be 15. So I'm going to come down to 0.01 and my two-tail, and I'm going to look at the degrees of freedom of 15, and I see 2.947. So this is how we would do a t-hypothesis test, right? Hypothesis test using a t-distribution, whether we are given summary statistics or given